Let's see how to define external fixities in StrueBIM Cype 3D, which are the ones that restrain the displacement or the rotation of the nodes in the structure and correspond to the supports on the ground and to other external elements in the model. We start by opening the Node menu at the top of the interface and clicking on External Fixity. Then we select the nodes where we wish to define the fixity, either one by one or all at the same time by using the crossing method with the mouse pointer. Lastly, we right-click the mouse. In the pop-up window, we can select the type of external fixity. By default, a recently entered node will be free, meaning it will not have any external fixity. The other options allow an external fixity to be defined in the node. With generic, we manually define the restrictions of the displacements and the rotations in the three-dimensional space. For independent displacements, we specify their behavior in the three axes, dx, dy, and dz. If the independent displacement is free, displacement in that direction will not be coerced. If it is fixed, it will be coerced and will assume a fixed value. By default, this value is null, unless we have activated the prescribed displacements option in the load menu, in which case it will assume this value. If we select elastic, the program assumes an elastic support in that direction, and the elastic constant of the support must be entered in the specified units. For displacements on a straight line, the node can only be displaced in the direction of the direction vector defined by the x, y, and z components entered on the right. In the directions perpendicular to that straight line, we specify whether the support is fixed or elastic. If the displacements are defined over a plane, the node can only be displaced in the plane perpendicular to the vector defined by the x, y, and z components entered. Similarly, in the direction perpendicular to the plane, we specify whether the support is fixed or elastic. In the Rx, Ry, and Rz rotations, we select free if the rotation is not coerced in the specified direction, fixed if the rotation is coerced and assumes a fixed and null value, or elastic if the coercion to the rotation is elastic, in which case we must enter the constant that regulates the support's rotational stiffness. The other options in the external fixity panel correspond to predefined external fixities that simplify data entry to speed up the process. Among the most useful is fixity, that prevents displacements and rotations in the three directions of the selected node. And pin connection, that only prevents displacements, allowing rotations. We can also define the free displacement over any straight line in the x, y, or z directions, or the free displacement over a plane parallel to axes xy, xz, or yz. The options in the first row also coerce rotations, while those in the second row keep the ones without coercing rotations. In all these cases, the components of the direction vector or the vector perpendicular to the plane are already defined, so we only indicate whether the displacement or the rotation in each one of the directions shown is fixed or elastic. Lastly, we can also define free displacement over any straight line, or free displacement over any plane, either with coercing rotations or without coercing rotations. In this case, users must enter the direction vector components.